In this video, we will discuss what is hierarchical clustering. So, in last video we discussed what is K-means clustering, that is centroid based clustering. This hierarchical clustering is a connectivity based clustering. There are two major types within hierarchical clustering. One is agglomerative, that is called agglomerative nesting like Agnes. We will see that in detail in this class. And the other one is divisive analysis like DIANA or DIANA. So, divisive analysis DI and DIANA from analysis. So, divisive hierarchical clustering or agglomerative hierarchical clustering. So, for the Agnes we build a tree from a bottom up, we will see what is tree, what is the bottom up is, and we will stop when we reach the root. So, for Diana it is just opposite. We will start from the top and we will reach when we reach all the data points, all the childrens in the given sample. So, we will see what is exactly this bottom up and top down approach, what is the difference between Agnes and Diana. So, we will discuss only the Agnes in this course. So, it is simple, you can understand how the other clustering algorithm works. Let us see hierarchical clustering. The same data set, but I think some points were removed just to make it simple. The idea of hierarchical clustering is that you have to pick each and every data point as a cluster, because it is a bottom up. So, the number of clusters here is 8, all the data samples is a cluster. So, each and every data point will act as a cluster. Okay, this is everything is cluster. Then you merge the most similar points. So, these are very similar, maybe this can be another cluster, something like that. So, you merge the most similar points in next step, then merge the most similar points in next step. So, till you reach all of this belongs to one cluster, till you reach the last step, that is all this belongs to one cluster. So, you make a multiple levels. So, how do we merge the most similar points? There should be similarity measure, right, like last time we saw what is a Euclidean distance to measure distance between centroid and the data points to pick which cluster to go. Similarly, here we also have to have similarity distances, right. Some similarity measure has a various formulas, okay, a lot of formulas. It is not important to know all the formulas here, but understand there is some similarity function which measures the similarity between the 2 points. If it is similar, if this point is more similar to this point compared to this point, these two will be merged first as a step 1. Okay. That is how the similarity measures is used. Let us see how this works in multiple steps. So, the first step what I did, I considered every data points as a cluster. So, we start with 8. So, what I say, it is all the 8 of them here. So, all the 8 of them here are clusters. So, in the step 2 we merge the most similar data points. By some measure these two are more similar compared to these two. So, this is a one cluster, this is another cluster, this is a 3 cluster. So, now we have 5 clusters, 1, 2, 3, 4, 5, we have 5 clusters as the step 2. Okay. Now, this cluster and this cluster is similar compared to the other cluster. So, this is formed as another cluster, this 2 on this 2. So, by some similarity measures, okay. Consider now we have 3 clusters, 1, 2 and this one, that is 3 clusters at step 3. At step 4 we might have another cluster combining these 2. So, now we have 2 clusters, and at step 5 we have one big cluster. So, number of steps is not depend on the number of data samples, instead it depends on the behavior of the data sample. Okay. So, it is like 8 data sample, it should be 5, no, it is not like that. 8 can be converged in 6 or 7 steps or 3 steps, or based on the behavior of the data. Okay. So, this is what hierarchical clustering, this is called actually agglomerative clustering. Agglomerative clustering starts with the one data point and tries to create a clusters with neighbors or similar measures. So, this cluster will be described very easily with the dendrogram diagrams. So, dendrogram is the another type of visual representation which we did not see in descriptive analytics, because we will see this. So, I thought not to discuss that multiple times. What is dendrogram diagram does is, this is not actual dendrogram diagram plotted from any library, instead I just drew this dendrogram in the PowerPoint. So, let us see how this dendrogram works. Let us see how it works. If we give a numbers to some of the values, let us see, let us assume some numbers 1, 2, 3, 4, 5, 6, 7 and 8. Okay. That is the numbers 1, 2, 3, 4, 5, this is 4 and 5 and 6, 7, 8. Okay, that is kind of some changes here. This is not exact dendrogram, but let us see how it comes. If you consume that 1, 2, 3, 4, 5, 6, 7 and 8, these two are similar measure, there is a distance similar. So, this will be combined as a one cluster. So, this is a step 1. Okay. At step 1, these two will be combined, and these two will be combined, and these two will be combined, and at steps 2, and this cluster and this point will be formed as a new cluster. It is a node, this particular node there are one cluster, and these two is there and these two is there. So, if I draw a line here after step 2, I should have 3 clusters, right, 1 cluster, 2 cluster, 3 cluster. If I draw a line at say at here after step 1, I have 1 cluster, 2 cluster, 3, 4, 5 clusters. Initially I had 8 cluster, then I choose a 5 cluster, then if I choose 1 I have like 3 clusters, I can see 1, 2, 3. If I draw the next steps, these two are combined to a new cluster at step 3, then if I draw a line here, I should have 1 cluster, 2 cluster, then there is one more cluster, there is only 1 cluster after step 4. So, this dendrogram tells that how to represent agglomerated clustering in the visual format. So, if you have a data, if you run Agnes algorithm, you might get this dendrogram diagram on your data points, and that tells you how this clusters are formed, and you can choose which level you want to go. So, I want to say I want to have 3 clusters, then these data points will be considered as one cluster, this is another cluster and this is another cluster. So, you can create where you want to choose. Each data point is each student ID. So, because you use each student's behavior, right, student 1's mark versus midterm. So, each data point is each student's ID. So, I just wrote it the sequential manner like 1, 2, 3, but if you really look at the data point, this might be different. So, the 3 students belong to one cluster, other students belong to other cluster, other 3 students to other cluster, we are forming into 3 clusters. So, this is how the hierarchical clustering can be used. So, to implement hierarchical clustering, there are a lot of tools available, we will also discuss some tools for that. So, give the data and compute the hierarchical clustering, and you choose your level based on your data and your need. Okay. So, hope you understood what is dendrogram and what is hierarchical clustering. So, can you list down 2 drawbacks of hierarchical clustering algorithm? After listing it down, resume the video to continue. So, it is not easy to decide number of clusters, but you have a complete picture, like what if the cluster value equal to 1, what if cluster equal to 2. So, you have complete picture, there is no need to have a elbow method or compute the error function, there is no error function here because, but you have complete figure. So, you know where to choose, and the distance of the lines also important. I will tell you what is that lines in next video, but let us see. There are different similarity functions, one is single connection or single link or average. There are a lot of similarity functions. You should choose a right similarity function, and some similarity functions have sensitivity to outliers. So, if there is outlier, some similarity function may not work. So, you have to understand which similarity function to choose. So, that is one drawback, I did not discuss that, but you can check what are the similarity functions used in hierarchical clustering. And the main problem is time complexity. So, n squared times it takes at each step. So, if we have say 4 steps, that will be like 4 times n squared times just takes n square number of clusters at each step. If you have like first step 8, that will be like 8 square 62 times 64 computationally costly happens at the step 1, then it will combine into 5 clusters, then 5 square times it takes. So, it will go in a logarithmic scale of complexity, which is highly computationally costly, also time consuming. If a very small data set which we collect from 60 students with 4 or 5 features, do not worry about those things. So, for this 60 students data 5 variables or 10 variables, this time is not really important. For very large data sets, you want to do a clustering in real time and you want to give a feedback in a real time, there the time is important. Okay. So, when we talk about time, you also have to consider where you will be using, is it in offline or in a real time you want to use this clustering technique. So, consider that. So, yeah, hierarchical clustering has a couple of drawbacks, but it is easy and visually appealing, but we do know how to choose the clusters. So, some places in research we use k-means clustering, in other places we use hierarchical clustering. Okay, we will see the example of both k-means clustering and hierarchical clustering in a research paper in the next video. Hope you understood what is hierarchical clustering, and thank you.